All right, so we're back, and now we're going to talk about how to find the median. And I'm going to keep using this data that I have up here, so I'll just make this more like it's a border, and we'll look at how to find the median for this sample we have of 12 people who have been arrested different numbers of times. So the first way to find a median, and probably the easiest one when you're working with a small data set like this, is to just put them all in order and find the middle by hand. So I'll start by just listing out these observations in order from least to most. So we have 4 zeros, we have 3 ones, we have 2 twos, we have 1 3, and we have 2 fours. So what I have here is this same data, just in order from least to most. And what you can do to find the median then is to just count inwards from the outside. And move in with your fingers each time until you hit the middle. And if you do that, you'll reach the middle, and you can see here that our 2 middle values in this distribution are both 1. When this happens, if they're the same number, you can conclude that the median is 1. If you were to get a different number here, what you can do is add together and then divide by 2. So if you had a different number for one of these, so if this one, for example, was a 2, so if one of these people had been arrested 2 times instead of 1 time, then you would add them together, 1 plus 2, divide by 2, and that would give you 1.5 as a median. So in general, what we're doing here, again, is we're just counting inwards until we find the middle. This middle value was actually a 1. So with 2 ones in the middle, we would say we have a median of 1. If they are different values, then you can add them together and divide by 2 to find the middle value. So I'll just make a note here in case for when I post these as notes. This would be if the middle values were 1 and 2. Alright, so that's one way to find the median, is just counting by hand. So going in from the outside until you get the middle, where you can see that both values, as we had originally written out, were 1. The downside to me doing this in pen is that I can't do what I like to do on the chalkboard, which is just erase things and draw over them as I make my point. So apologies for the scribbling that I've got going on here. All right, so the problem with doing this method for finding the median, though, is that oftentimes you'll be working with really, really big data sets. And you can imagine if you had a data set with 100 values in it, or 1,000, or even 10,000, it really wouldn't be feasible to go through and, count towards the middle. And it can get pretty cumbersome pretty fast. So one of the things that you can do instead is find the median position. And what the median position does is tell you where in the line to look for your middle, so that you don't have to actually count. You're also less likely to do what I almost did while I was counting, which is like accidentally count a comma or something. So I'm going to write out the formula for the median position. And the median position tells you where to find the middle value. So I'm going to call it MP. And we find the median position using the formula n plus 1 over 2, where n is your total number of observations. So in this particular data set, our median position is going to be found by 12 plus 1 over 2, because we have 12 observations total. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If you do the math, you get 13 over 2, and that comes out to 6.5. So we have a median position of 6.5. Okay, so what do we actually do with this median position? As I said before, the median position tells you where you can find the median. And I'm going to just write this out again because I've already scribbled enough on that one up there. And so what we have here is a number of values in a line. And the position refers to where they are in the line. So for position, we would say that this one has a position of 1, this one has a position of 2, this one has a position of 3, and so on. All the way up to here, where this one at the end has a position of 12. The median position tells you where you find the median. So here we have a median position of 6.5. If you ever have a 0.5 in your median position, what you want to do is look at the numbers that are on either side of it. So here, with 6.5, we have 6 on one side, and then we have 7 on the other side. So 6.5 fits right in here, in between 6 and 7. And you can see that where I'm going to be drawing this box now, around positions 6 and 7, is exactly the same place that I drew the box here when I counted inwards. So what the median position does is it saves you the trouble of counting, and it tells you exactly where in your line to look to find the median. So here we're going to come to the same conclusion, which is that the median is equal to 1. So our middle two values are both 1s, and so we don't need to do any extra calculations. We know that our median is going to be 1. So here we'll say again, the median is 1. Now finally, you can also use the median position to find the median using a frequency distribution. And in order to do that, you're actually going to be using the cumulative frequency. So what I'm going to add here to this frequency distribution that I wrote out is the cumulative frequency. And cumulative frequency, if you remember, you get by doing that diagonal addition. So I'm going to write out the same cumulative frequencies that we would have found last week. And we want to double check our cumulative frequencies, so our first cumulative frequency is the same as our first frequency, our last cumulative frequency is the same as our total, so we know we're good to go there. And to use the median position to find the median in a frequency distribution, what you want to do is figure out which of your two cumulative frequencies your median position falls in between. So just like we looked at which two of our positions it fell between, we're going to look to see which two of our cumulative frequencies it falls between. And in this case, we've got 6.5, so it's going to fall in between 4 and 7. When you do this, so you've got 4 here and 7 here, with very few exceptions, which we're not really going to go into, the larger value is going to give you your median. So the larger value here is 7, and 7 is the cumulative frequency for 1, which is our median. So this is our mode, and this is our median. So again, I'm just going to talk through what I did there, which is that I found which of the two cumulative frequencies that the median position falls between, and then I looked at the larger one to find my median. So 6.5 falls between 4 and 7. The larger of those two values is 7, and that value of 7 is the cumulative frequency for one arrest. So that tells me that our median value of number of arrests is 1. And as it should be, it's the same value that we got when we used the median position in this list of values, and it's the same value that we got when we counted inward using this list of values. So when you're calculating something, you want it to always come up the same each time, so it's a good way to double check this as well. And if you're wondering why you're looking at the larger of these two values and what exactly is going on here, one way to think about the cumulative frequency is that it's telling you at which position you're hitting the last of a particular value. So we have a cumulative frequency of 4 here, and if you look, position 4 is our last 0. We have a cumulative frequency of 7 for one arrest, and if you look here, 7 is our last value. And I have a cat who came to visit, so I'm going to get him out of the way. So we have a cumulative frequency of 7, and a 7 is our last one here. Just to keep going through this. Sorry, I have a cat all over me now. We have a cumulative frequency of 9 for a value of 2, and then 9 is our last 2. And then the same thing here. So what these cumulative frequencies are really telling you is just, if you list everything out, kind of what's the last position that you see each value in. So with that in mind, looking in between these two values, it's telling us that we're looking between a bunch of 1s. Sorry, it's telling us that our median position is in this group of 1s here that's between this 4 that tells us where our last 0 is and this 7 that tells us where our last 1 is. Again, sorry if that was in any way garbled. I get distracted every time the cat walks around on top of my computer. Alright, so we have two ways of calculating our median value here using the median position, and again, one is to just look for where your median position falls in between your two positions. So median position of 6.5 falls in between 6 and 7 as positions, or look at your cumulative frequencies, and you can see where it falls between your cumulative frequencies, and then pick the larger one, and that'll tell you what your median is, for the short and sweet version of it without all the extra explanation. Alright, so with that, I'm going to go back into the PowerPoint and talk about the median in the class data, as well as our last measure of central tendency, which will be the mode.